Good evening, everyone. Want to welcome you to the final Night with the Experts of 2024. This is a monthly program hosted by the Nuclear Energy Information Service. We're based in Chicago, and we've been doing this about 3 years now, where we bring experts on nuclear issues from literally around the world, not just around the country, to you, where you'll have an opportunity to not only hear what their area of expertise is, but you'll have an opportunity to engage in conversation, uh, various dialogue, question and answer, and back and forth at the very end. So again, my name is Dave Kraft. I'm Director of Nuclear Energy Information Service. I'm awaiting my colleague to join us. She's having some computer issues tonight. Her name is Jan Boudart. She's a board member of NEIS, and hopefully she'll be joining us very soon. So tonight's guest, as you can see, is Aaron Datesman, who is a co-author and researcher. Just came out with a partnership book called Dirty Secrets of Nuclear Power in the Age of Climate Change. And tonight, we're going to be discussing the issue of low-level radiation and radiation exposure, which is something which is not well understood or known about. So I'm eager to hear what you have to say. I'll mention also tonight's program, as we always do, is being videotaped. So if you really don't want to be on video, turn your camera off. We will also be making the chat available, not at the beginning of the session, but after the speaker is finished with the presentation. And we will be sending the chat around to everyone who participates tonight after the session is over. We find that the chats are usually very rich in commentary, links, suggestions for each other. So I'm going to take over for Jan's usual role. She'll catch up with us a little.
I think I'm back.
Oh, very good. You are back. Welcome, Jan Boudart from the NEIS board. So I will send it over to you, Jan, to do the introductions of Aaron. So thank you for joining.
Well, I think I lost my internet for a few minutes and I had to power up everything. You know, I'm not prepared to introduce Aaron right now. I kind of got rattled. If you can give me just a minute, I'll be right back. Is that okay? Or
well, I see some thumbs up, but also I did a very light preliminary intro. The fact that he's a researcher, he has the book coming out, and we did the topic. So if you don't have any objection, we'll go straight to, you could do the intro, Aaron.
There was a short bio of him on the flyer that we sent out.
Right.
You know, the MailChimp. And I'm afraid you're just going to have to give me a little second here because I got kind of rattled.
I'm willing to just go ahead. I'm a house husband who used to work in NASA in the Department of Energy, and I published a book, and I want to talk about the book a little bit.
Yeah, all right, go ahead. I do apologize for being so discombobulated.
I think that's fine. I have a bunch of slides, and I think I can just take the share, David, and go ahead and start talking. Is that fine?
You're all set to go, Aaron. Thank you very much.
Okay, so we're gonna try this. Okay, give me a moment while I navigate to Zoom and bring up PowerPoint and go away. There we go. All right, and okay, you should be seeing a screen that says there is no such thing as a low-level radiation exposure. If anybody is off of mute, can you tell me that you see what you should see?
I definitely see it.
Great, thank you. Okay. Please pardon my voice. I came down with bronchitis this week. I'm going to do my best. I'm aiming to speak for 20 minutes. About half of that time, I hope to give a non-mathematical explanation for this title. And the other half, I want to talk about 3 Mile Island a little bit. If I'm unclear, please just interrupt me and let's talk about what we want to talk about. I have lots of extra slides, including some math in the middle. If we can have a discussion about any aspect of the book that you'd like to talk about, if you happen to have read the half of the book that I wrote, especially the second half, at the end. And also a big thank you to Jan and to NEIS for this invitation. I used to live in Chicago. Anything that touches Chicago is all right by me. It was wonderful that somebody read chapter 7 of the book and thought it was noteworthy. I really appreciate that.
Well, my goodness, it certainly is noteworthy.
All right. Okay. So I don't wish to read slides, especially because my voice is failing me. Collaborators, I definitely want to express my appreciation to Heidi Hudner of Stony Brook University and Doug Briggy of UConn, who was the co-author of this book. The book was his idea. You're going to see a preview of Heidi's movie about 3 Mile Island later on in this talk. We've had such a wonderful and productive collaboration, and it started through social media, which is a remarkable story all on its own. There's some math in the middle that I decided to cut out. Unfortunately, this is a mathematical topic, and I mostly think there's no substitute for doing the work. So if you really want to understand this, I will teach you, but it requires some algebra. And as a third point, the idea I'm presenting, which I call the hypothesis of shot noise in radiobiological systems, is a scientific hypothesis, meaning that it isn't proved, it's a hypothesis, but it's scientific because it is falsifiable. So we're discussing an idea that is not proved. And if we are honest with ourselves, we keep that in mind as we progress to think about this idea.
Aaron, what do you mean that it's falsifiable? Don't you mean justifiable or
No, I mean, a scientific proposal has to be falsifiable, otherwise it's faith. So what I mean specifically is that I have designed an experiment that I've not yet been able to conduct, which will either verify or refute the contention. And at the end of the talk, I'm happy to discuss what that experiment would look like and what we're trying to do to get it done.
Okay.
Okay, but thank you for the question. Was that Jan?
It was me, yeah.
That's a very good question. I should also express my appreciation to my wife, whom I think is listening while driving in a car with my children. This wacky thing that I've done with her love and support entirely, and I really appreciate it. And maybe all of you will as well. We'll see. Okay, housekeeping matters. There are 2 things that are important. These are scientific ideas you have to understand what's coming next. We're talking about ionizing radiation, which refers to radiation that has enough energy to free a bound electron from an atom, so that electron is then present in the material and available to do bad stuff via chemistry, because a free electron is chemically very active and damaging. So we're talking about electrons. The reason I have come to this knowledge is because I'm an electrical engineer, which is a discipline dealing with electrons. Second point is my training is in detector science. I worked as a detector scientist for NASA and for the Department of Energy. We're using the mathematics that's established in detector science to think about the process of chromosomal injury. Within the field of cancer research, it's believed that about 1 in 5 cancers are due to an alteration in a chromosome. So, there's at least that connection to the genesis of cancer. Okay, and as a last point, there's actually 3 points here. I'm mostly speaking about a field called microdosimetry, and specifically some assumptions embedded in microdosimetry that I think are incorrect, or at least not generally true. So this is kind of a turf fight between nerds, but it has big ramifications. Okay. I said I was a NASA guy. This is the kind of thing I did at NASA. I designed and built, these are superconducting microcalorimeter detectors for characterizing the heliosphere of the sun. They're X-ray detectors, but they don't get cancer. Okay. 3 things. This is kind of a bona fide, about my bona fides. This is the book, Dirty Secrets of Nuclear Power in an Era of Climate Change, that Doug was kind enough to invite me to co-author. The foreword is by Helen Caldicott, whom I'm sure you all know her name. It is an open access book. You can go online and download an ebook, and it's free, which we like. Doug and Heidi and I all met because I published an article in a journal called Scientific Reports, which is an open access journal, about radiobiological shot noise, that's the hypothesis, and 3 Mile Island biodissymmetry, that's biological dissymmetry, showing that people were severely harmed by the accident in 1979. So there's a hypothesis that I offer as a possible explanation for an observation that maybe many people have not heard about. And on the left, you're the first audience tonight who's going to hear some pieces of a new article I'm about to publish called The Dose Rate Quantum. So this is unpublished material that will go to a specialist journal, but I'm going to tell you a few pieces of it tonight in the context of chapter 7 of the book. Okay, so I will speak about authorities, and when I speak about authorities, which I will do after I take a sip of tea, one of those authorities is the National Academy of Sciences. And you may have heard about a report called BEIR7, that is the Biological Effects of Ionizing Radiation, the 7th edition about low lead radiation, meaning X-rays and gamma rays. When the government wants to know what to think about a technical topic, very often it turns to the national academies to write a report to tell it what it should think. So that's what BEIR7 is. And in this report, you'll find information like 1 out of every 3 Americans should expect to get cancer in their lifetimes. A 1 sievert exposure corresponds to a 5% increase in cancer risk. That information comes from BEIR7. I have excerpted a piece of BEIR7. I'm going to tell you a little story. In 2011, I was working in the Department of Energy in the Forrestal building downtown. And Fukushima happened, and Forrestal used to be the headquarters of the Corps of Engineers. And it's got these very sterile rectangular hallways that are incredible for pacing. And Fukushima was happening. You could go and watch the reactors exploding, on YouTube. I think we had YouTube in 2011. And I kind of wanted to know what would happen. So I went and I read. I did what nerds do, and I read. And one of the reports I read was BEIR7. And it has this statement about proportionality. If there's 1,000 ionizing particles, if there's 100, if there's 10, the risks are proportionately lower. And I read this and I thought, Jesus Christ, this is totally wrong. Let me take another sip of water here. Because I was educated in engineering, and I know that random processes, and radiation injury is a random process, don't scale linearly. And this is a perfect example of what the authorities believe. They consider the number of events, which is an example of an amplitude, without considering, as nature considers, the frequency of events, meaning how often they occur. Nature, and it's nature that's the final arbiter, is concerned with both amplitude and frequency. So I learned that really at the highest level, this scientific agency, the National Academies, full of highly credentialed nerds, believes unscientific nonsense. And that's in my view, that's a serious problem. Okay. And I am speaking slowly, so I've reached my halfway point and I'm nowhere near. Just the last bullet point here is the important one. The temporal, meaning with time, distribution of events is fundamental. In microdissymmetry, they don't consider the temporal distribution of events. They assume that everything happens all at once and then build a framework from there. And that treatment is fundamentally not how nature sees the matter. It's not adequate for low dose exposures. Okay, I need everybody to unmute because this is the part where you participate. This is a quiz. What's this, guys? Who can tell me what this is?
Electron.
Negatively charged electron.
This is an electron. Okay, you guys are good students. This is an electron. Okay, 100%. That was outstanding. Okay, what is this?
That doesn't exist.
Impossible.
I think you guys read my book. Okay, this is a fiction. This does not exist. An electron is an indivisible particle that cannot be divided. It comes only in packets of 1, 2, 3, or many. What does the joke mean? Okay, that is my wife added this and I like it. It is a fictional fractional figment. because events are discrete and indivisible. Okay. Just on this basis, the linear model, called the linear no threshold model, or LNT, is not scientifically supportable. That is a radical statement that I stand by. I think it is certainly correct. And I think probably in their heart of hearts, no scientist would dispute that, but they must believe that the point at which, excuse me, hi Maggie, I'm talking, honey. Okay, okay, little girl. They might argue about what is the point at which this matters? Where does this become a problem? And the answer is actually, this is a problem for all exposures below a dose rate of about 100 gray per hour, which is a very high dose rate. Any environmental exposure is well below the limit at which the indivisibility of an event becomes a serious concern. Okay. I'm going to ask if a couple people would unmute. I don't care who, and tell me how I'm doing for clarity and speed. If I could have a little feedback. It could even be you, David, if everything
You
is
sound good.
okay. That's good. All
And
right.
I also think you don't need to pay too much attention to the limit of time. We're really interested in what you're saying, so you go ahead and do what you want to do.
Okay, that's great because I was blowing right past it. Okay. So I have a couple more slides in the same vein, but we're gonna see. Okay. I think of this matter in sort of discrete terms as events are binned into little divisions of time. So let's think of a bin. The bin covers a certain duration of time. That duration, in fact, is very short. It's a billionth of a second, a nanosecond. But let's say there are 5 events in a nanosecond, and then we extrapolate downward. In this other 1 nanosecond interval, there's 2 events. We're extrapolating. The linear model says you can extrapolate from high doses where you can discern effects down to low doses where you really can't. So what comes next? Well, let's unmute again. What is this? What do we have here?
One event in 2 nanoseconds.
We have 1 event in 2 nanoseconds, or we have half an event per bin as an average matter. But the important point here is that what we have, in fact, is a new domain. We have made the transition from the domain of amplitude, 10, 5, 2, 1 events, down to 1 event per 2 bins, 1 event per 5 bins, 1 event per every 100,000 bins. It's the distinction between amplitude and frequency. The National Academy of Sciences, in that front matter that I took from, talks about amplitude, but they never talk about how often the events are happening. They don't think about it. Nature has to think about both amplitude and frequency as you extrapolate downward. That is, I think, the clearest statement I can make. But we're going to see a movie that I hope clarifies this idea a little bit. Okay, in the book I have a figure I call the postal warehouse explanation. You can read it. I've really already covered it. The point is, moving from left to right, you look at the distribution of mail pieces in postal bins on the left, and the question that's being addressed there is clearly how many events occur in every bin. There's about 30 events in every bin. Whereas when you go to the right, you ask, how often does an event occur in a bin? And here you see there's 3 events in 100 bins, or 0.03 events per bin. The character is changing from how many to how often. And nature has to have an answer that that applies in both domains.
What?
Okay. All right. So I'm going to play this and then pause it. Okay. So on the I'm going to spend a moment on this to try to make it comprehensible. I know it's a little confusing. I have plotted out the occupation of 100 bins along the x-axis. So 0, 20, 40, 60, 80. There are 100 intervals, excuse me, of 1 nanosecond on this graph. And this character mu, that's the Greek symbol mu, equals 3.94. That's about 4. That's called the expectation value. That describes a probability that the average bin will have 4 events in it, but some will have, this bin has 5. These bins have 6 or more. It cuts off at 6. This bin has 3 events. This bin has 1 event. That's the expectation value. MS is the mean square. So if I go across and I add up the square value of every bin, and then divide by 100, that'd be 21. That kind of makes sense, because if the expectation value is 4, 4 squared is 16, so the mean square is a little bigger than 16. And the frequency means how many bins have at least one item. And here you see the frequency is at 100%. All the bins are full. Now I'm gonna press play, and what's gonna happen is every frame, I extrapolate the expectation value downward. And what you're going to see is the heights of these peaks diminish. And then something else happens as well that you can track by reading what the frequency number says. I'm pressing play now. I can go back and play it again. I'll probably play it a couple times until the messages may be clear. And I'm going to stop talking. Just watch the movie.
There's no movie to watch. We can't see it.
Oh, you're not seeing that. I thought it worked before.
I can see it.
Yes, we can.
I can see it.
Yes,
It's working very nicely.
I
Okay.
can
Like
see
a
it.
rapid
I can see
slideshow.
I
Okay.
can't see it at all.
Okay. I apologize for that. These slides will be available after. If you would like, you can download the slides and watch the movie. Okay. I'm going to play it again. And then I'm going to talk over it a little bit, and then we'll move along because time is going. What I want you to watch is that about the time when mu equals 1, the frequency starts to drop precipitously, and the events never fall further in amplitude below 1 unit, but the frequency starts to fall down to 0. And in fact, if I had 1,000,000 bins, you would see the frequency go 0.1, 0.01, 0.001. Okay, I can play it one more time, and I want you to watch. The amplitude of events is anchored at 1. It can never extrapolate below 1. That's because an electron is an indivisible event, and you can't go below 1 in amplitude. Okay. Having made that point, I'm going to ask again, is that sensible? Does everyone follow that at least a little bit?
Yeah.
Yes.
Don't all.
It's
don't
a
Yeah,
all-
yeah.
That's
Yep.
okay. Wonderful. All right. So now this is the end of the first portion of the talk. So I only went 10 minutes over. The title was "There is no such thing as a low-level exposure to ionizing radiation," and I just explained to you why that is. So if you think about what that movie looked like at the end, where you had just a couple events widely spaced with nothing happening between them, I've reproduced a diagram like that. Now the pulse heights here are different because in a physical system, the electrons have a spectrum of different energies, so they're not all the same. But the pulse widths remain very narrow. The width of a bin is only a nanosecond. And I wish for you to think about this very carefully. Okay. During that interval of 1 nanosecond, there is a great deal of energy delivered very quickly. So the instantaneous dose rate is very high. So in one of these pulses, the instantaneous dose rate, which I would describe in fact as a dose rate quantum, a quantum meaning an indivisible unit, is hundreds of gray per hour, which is a very high exposure. Meanwhile, in the case of the 3 Mile Island exposures that I will talk about next, the average dose rate, I wrote it down here, is 2 microgray per hour, which is a very, very low dose rate. The authorities say an exposure at that low dose rate, at that low dose, can't be harmful. But I wish to point out the following idea. The authorities will say, it's the consensus view, that a cancer today may very well have originated as a single instance of damage or a single defect in a single cell 10, 20, 30 years ago. If that's true, and I have no reason to doubt it, how much sense does it make to try to relate that event to an average dose rate that never occurs in any cell? It doesn't actually appear. Instead of to the exposure, the dose rate at the instant in which it actually occurred in the cell in which it actually occurred. The answer, in my opinion, is it makes no sense. And you really have to refer that event to the instantaneous dose rate that caused it. There has to be a causal relationship. So at the end of this talk, I'm going to say there's no such thing as a low-level exposure. There are only collections of high dose rate exposures that persist for very brief intervals of time. It is not a semantic distinction in any way. It's actually incredibly important. Because if you believe the average dose rate is representative, you can't understand, for instance, evidence of cytogenetic damage at 3 Mile Island or from other low dose rate exposures. And the authorities say this damage cannot have happened because we can't explain it based on the doses that arose. And I think the reasoning is a fallacy. I think there's a logical fallacy there. Okay. So I'm going to take a breath, and if anyone would like to ask a question, I think now would be an appropriate time because we're going to go and talk about 3 Mile Island instead.
John,
Yeah, I have a question. Okay, I mean, what you're talking about really is at such a micro level and so fast. You know, you're talking about a very discrete package of energy arriving at a cell level in an instant, and then, you know, but it's a very high exposure for that instant. Do we have an experimental model that shows that? Do you know what I mean? That can show this chromosomal damage given that minute quantity of high level energy?
Okay, that's an excellent question. I'm gonna answer it by telling you you're half wrong. Okay. It is not actually a minute volume. In the picture on the right, I trained as an electrical engineer, and scanning electron microscopy was one of my specialties. So let's take a beta particle with 100 keV of energy and shoot it into water and ask where all that energy winds up. Okay, this is a picture made with Monte Carlo modeling that shows where that energy ends up. And the distances in microdosimetry, they call this a site, although they assume that the sites are spherical. This is like a millimeter. So, and because the process is ergodic, okay, now I'm using some math terms. You seem to be technically savvy, but at some level you need to be like this. It's not actually happening at the cell level. Microdosimetry, in my opinion, is missing the forest for the trees. This energy is being spread among all the cells, many millions of cells, in a volume of nearly a milliliter. Now, as to the time, you're right. This realization about the very high dose rate is fundamentally depends on the choice of a very short time. The thing is, that's not arbitrary. Nature sets it. The duration of the size of a bin. I'm sorry, I'm a little tired, so I'm not speaking very clearly. The duration of a bin is 1 nanosecond because that's the lifetime of a hydroxyl radical in tissue. And the hydroxyl radical, OH with a hanging electron, is the primary species responsible for radiation damage. So it's actually nature that's setting the scales of volume and time. This isn't an arbitrary thing. I had to think actually really hard to understand exactly why this was. There's more information about this. There's a little bit about it in the book. There's more information about it in the dose rate quantum article where I make an argument using the Buckingham pi theorem that this must be the case. But I haven't published that yet. Have I answered that adequately? There are other.
No, absolutely. The connection to the hydroxyl radical is very helpful for me because I was trying to figure out how can this damage happen, and that's the pathway.
Yeah, wonderful. Thank you for that excellent question. There are 2 more I'm happy to entertain.
Yeah, Tracy McClellan wants to ask a question.
You referred to NASA in an ostensibly benign way. Can you say how you reconcile NASA's burning of fossil fuels with that judgment of it being benign?
That's a question that takes us afield from what we're talking about right now. I'd be happy to speak about that at the end, if that would be all right, Tracy.
Okay.
And David, what is your question?
Okay, so if I'm grasping this properly, my understanding is there are four possible outcomes when radiation strikes a cell. Nothing will happen, something will happen, it'll be repaired, something will happen and it won't be repaired and you end up with cancer, or the cell dies. Those are the four I'm familiar with. If there are others, I'm, correct me. But given what you said about exposures being high level for the most part here, wouldn't one expect more cell death or unrepairable damage to be observed in tissues?
That's a great question. I think the insight I would offer is that we've been sold a false dichotomy between high level and low level exposures because they're all high level exposures. So this has been true of all exposures all along. Just the conceptual framework we've used to describe exposures has not been correct. That's perhaps an unsatisfying explanation, but I think it's the correct one.
Okay, we can pick it up later. Thanks.
Yep. All right.
Move on now.
Move along now, if no one minds. Okay, there's a bunch of math here that if anyone wants to know, they can ask me about it later. But okay. I'm going to talk a bit about 3 Mile Island, in which there's a couple of my TMI friends on the guest list here, and I saw Linda and Joe, I think. So hi, hello. All right. I'm proud of the chapter in the book. It's 6,000 words, and yeah, I'd be delighted if folks would like to pick it up and read it. This photograph appears in the book. This gentleman is named Bill Peters. Linda, I think you may have known him. I found this picture. I'm really delighted with it on eBay. ABC News was clearing out its photo archives and they sold it to me. One of the themes in the chapter is that the authorities say if there were any health impacts from 3 Mile Island, it's because people were panicked and scared. And one of the things I point out in the chapter in the book is that this may very well be true, but there were also verified plant abnormalities. And I'm pretty sure the trees weren't scared of nuclear accidents. Mr. Peters here in his right hand is holding a deformed leaf of a dandelion with gigantism, which is a known impact of ionizing radiation. This map is this is a reproduction of the Columbia study, but I had a young man with GIS skills redo it. 3 Mile Island is right in the middle, and for the most part, the plume that was released, this is radioactive xenon, traveled in a low plume to the northwest, and this tract here, which is called number 74, covers the neighborhood of Shope's Gardens in Middletown, Pennsylvania, where I have some friends. Okay, about the 3 Mile Island accident. The accident released mostly radioactive xenon-133. In the most intense portion of the plume, it released about 1 microcurie per liter of xenon-133. That sounds like a very small concentration. I believe I've calculated out it's 1 part per trillion of the atmosphere, which indeed is not very much. But the amount of xenon-133 released by TMI in 1979 had the activity of 22 metric tons of radium 222. A metric ton of anything is a lot. A metric ton of radium, if you actually had a cube that size, would certainly kill you immediately if you stood next to it. So that's not a small release, and I would dispute anyone who described it as a small release. However, the scientists who did the modeling to determine doses to the population, and on the right here, this is a picture of sort of schematically how they thought about it. There was a release that they measured via a strip monitor in the auxiliary building. The output of that monitor is here in the middle. They input that data into a meteorological model of the wind conditions and the temperature, and then they projected out what the doses were to individuals at different locations. The finding was that no person received a dose larger than about 2 millisieverts, which is about equal to annual background radiation. And on this basis, the authorities say, well, nothing happened. That's a low dose exposure. Well, you know, I gave an idea that what I think about low dose exposures. All right. Okay. And now, if no one minds, I'm going to give a plug for my colleague Heidi Hudner's excellent documentary movie, which will has been shown a number of times in the U.S. and I think it's going to Taiwan and Italy in the coming year. It's called The Women of 3 Mile Island. Hi, Linda. Don't be.
It's on Amazon.
Once the accident
as well.
happened, we started getting phone calls asking if we had heard about 3 Mile Island yet. They are having a meltdown.
It was the first step in a nuclear nightmare.
There is no cause for alarm or any reason to disrupt your daily routine.
Officials were lying about what was really happening.
When an accident like 3 Mile Island happens, the first line of duty is to reassure the public.
The safety systems were designed to take care of this kind of an accident, as our safety systems did.
I was being told the media is blowing it up.
The reactor core is indeed stable.
All I kept thinking was, hopefully I got my kids out of town in time. But I've come to find out I didn't. My whole world was turned inside out.
3 Mile Island blew up like an atom bomb. People suffered an exposure equivalent to 100,000 X-rays.
Radiation is more harmful to females.
It's the first time we've had cancer in our family history.
We will see an increase in the cancer epidemic that is already running rampant in this country.
Everybody went rushing to see the China syndrome to try to figure out what had really happened at 3 Mile Island.
So much radioactivity was coming off of the reactor, the monitors couldn't read it.
The company covered it up. It all came out.
All hell broke loose.
Most of the people here have been arrested and taken away.
It's one of the biggest cover-ups in history. They lied and lied and lied.
I can't keep living like this. I need answers.
It's possible using new technologies, testing the people affected by the accident to see what level of genetic damage is there.
This is my family that they played with.
Do not believe what the company tells you and question everything the government tells you.
Okay.
Once
Watch again. All right. Okay. Let's see if I'm still. Okay. Can everybody hear me? Anybody hear me?
Yep.
I can.
Okay. All right. Great. The movie is available on Amazon Prime and Apple TV, and I recommend it for more reasons than that I was wearing my nice suit, and it was nice. I will make the single comments. TMI didn't blow up like an atom bomb. I think that I say that as a result of editing for a preview. It melted down, and the exposures to individuals, according to Russian investigators, was similar to people who were exposed to fallout from the Soviet Union's first atomic bomb test in 1949. But that in its own right is an alarming finding.
Where did you say the movie is available to watch?
It is on Amazon Prime and Apple TV.
Perhaps we can put that in the chat when the chat opens up later.
That sounds like a good idea. Okay. So the reason I chose that introduction is because it's a good way to explain what we've been doing. Professor Briggy and I, with collaborators in Colorado, Susan Bailey, a professor at Colorado State University, and the staff of a commercial firm called Chromatid, have developed an assay. The idea that there's an assay is not new, but they have a whole genome 5-color assay for chromosomes. And so we took the blood of individuals who were in the path of the plume in 1979. We took their blood, and we are analyzing their a karyogram like this one, and it's a large number. There's more than 1,000 karyograms, looking for evidence of cytogenetic damage that may be linked to the exposures in 1979. Okay, I call this investigation 3 Mile Run. And I should mention again, I'm very grateful to Doug for being involved in this project and for providing the funding to make it happen. But just to explain what this is, I'm not a molecular biologist, so I still find these sort of amazing. But a normal chromosome, let's look at number 8 in this case, is normal. The fluorescent dye should all be on one side of the chromosome. in places where the dye switches, like on chromosome, well, number 2 and the first location here, this is called an inversion. And in this case also, this is an inversion. Whereas in number 16 on the squares, these are actually called sister chromatid exchanges, which is a different kind of aberration. But inversions, dicentric aberrations, and translocations, depending on the frequency, can all be evidence of radiation exposure. So what we are trying to do is to look again at a question that has been examined before. Russian investigators did look in 1994, and they found alarming levels of radiation damage in individuals that they examined. But the authorities don't believe that the Russian evidence is credible. And so we're trying to address that question as scientifically as possible by trying to replicate the results. I will show it. Okay, it sounds like there are questions. So let's hear a question. Sure.
Okay, I think Connie has a question from earlier. I had a question about this slide, but Connie, what's on your mind?
I have a question about, is this an actual slide from, is this an actual sampling slide from a 3 Mile Island resident?
Actual slide from an actual person who was actually living within 10 miles of 3 Mile Island on March 28th, 1979.
Okay, my follow-up to that is I have watched the movie. It actually made me cry.
Yeah, me too. In fact.
And I saw there was a little snippet of drawing the blood. Two things. Was any of the testing mouth swabs? Was it all blood? And are all the results back?
Pardon me. It's all blood. I'm not aware of a cytogenetic test using a mouth swab.
Okay.
And the results are all back. We're working to compile them now, and I intend to publish what we find, which I think will be quite a long article with lots of findings next year. We wanted to get it done this year, but it's been a little difficult because we don't have a staff, so we kind of work on volunteer hours.
Thank you. Thank you for everything that you're doing, and Heidi too.
Thank you for asking about it. Okay, we got some other questions. I'm happy to discuss.
Yeah, my question, just looking at the slide, if you look at number 6, the fluorescents are on the same, are on opposite sides of the chromosome compared to, say, 7.
I'm sorry, we are okay. I am looking at page 2 out of 2. Are we looking at the same page, or we're looking at 1 out of 2?
I'm looking, oh, well, now you just changed it, right? Yeah,
I went back to the first one. You're talking about number 6?
Well, now 6 is not the same as it was in the other slide, but what about number 14? Look, the colors are both on the left, but I thought the normal ones were like number 3, where they're on,
Yeah, the way that the chromosome sticks on the slide is arbitrary. That's not actually.
Oh, okay. All right. Thank you.
Yeah, I'm not really looking to give a course on how to interpret karograms this year. But thank you for the question. And then
John, do you want to ask a question? Is it okay if I, Aaron?
Yeah. But we're almost done.
Actually. Please. I'm just interested the challenge between causation and correlation. Is there a cytogenetic analysis of this blood prior to 3 Mile Island in these individuals? Is that possible? I mean, that's a retrospective analysis, but I just wonder if that is something that would strengthen, the correlation between that event and the cytogenetic abnormalities.
Questions like this keep me up at night and make me wonder what I've done with my life. It is a difficult question how to structure an investigation in a manner that gives a compelling answer at the end. For one thing, it's not really understood how these are immune cells, and it's not really understood what the different lifetimes are of the various components of the immune system and how that might figure in. So a radiation exposure that's investigated using biological methods by looking at dicentric chromosome aberrations, typically they say you want to do that within 6 months or a year. We're not using dicentrics, but we're looking 45 years later, and the questions are very complicated, including like, what else could have happened to these individuals beside 3 Mile Island? But to first order, the way to structure a study, and it's not a correlation and causation issue, so maybe I don't understand the question you're asking, is you enroll some people you believe to have been exposed, you enroll some people you believe not to have been exposed, you try to match them on relevant factors such as age and smoking, and then you compare exposed and unexposed. But there are second order things you can do as well that I could discuss, but that would go on for a long time. John, is that a reasonable answer to your question?
Yeah, yes, it is, and I can see that the actual experiment done within a time frame of before and after exposure is probably not possible. Impossible, really. I mean, I'm assuming that that wasn't done close to the time 45 years ago that they did. They maybe had blood samples of people prior to the event and blood samples after. They actually went and looked at both.
Well, it's interesting you say that because like a year or 2 years ago, I learned the Pennsylvania Department of Health, the state government, as you can imagine, they convened an expert panel and they asked the panel, tell us what we need to do to evaluate the health status of these people who were affected by the accident. And they came back with a list of monitoring things, and the state did some of them and didn't do others. And one of the first things they said is we should do cytogenetic testing of these people. The technology existed in 1980. And they should have done this in 1980, and if they had, they would have found, in my opinion, very alarming things. But then, 9 months later, they looked at how much it would cost, and they reversed themselves, and they didn't do it. And I really feel that's a violation of, well, A, their responsibility to the people, but B, also of scientific principles. You should try to conduct studies you expect to have a negative outcome, just because you might be surprised.
Yeah.
If you don't do the negative study, you're never going to learn anything, or it becomes much harder to learn anything.
Well, it seems that they would have had to
Okay.
have blood samples from before the accident of those
No,
people.
no. You could you can examine on a population basis, exposed versus unexposed. Otherwise, you have to keep blood from people in a cryogenic freezer in the expectation that there might be a
Right.
I think we should go on, Aaron,
Yeah.
and we'll go back to questions later when they start to arrive.
Okay. Okay. So I have 3 more slides. These are very quick. This is from the book. Jan asked me to address this question. My favorite answer to most controversial questions is that both things are simultaneously true. And this is one where I'm going to practice both sidesism. I think, on balance, having read hundreds of, thousands of pages and talked to dozens of people and all the work I've done over many years, the authorities are basically correct that the absorbed dose to any individual was small, a few milligray or smaller, about background. The conclusion is anchored to physical measurements using an electronic device called a thermoluminescent dosimeter and other electronic devices that monitored the emissions. Okay. At the same time, I think the biological impact to the most exposed individuals was actually severe. And you can read, there's a number of reasons that I think this is probably true. One of them is I think the evidence about plants is compelling. People are harder because people are scared and things do happen. But the plant evidence I find compelling as well. But also the epidemiology and the cytogenetic testing. Okay, how can this be? And there's a triangle. This is my answer. It's what I talk about in the book as well. You can measure a low-level exposure using physical means, and because most of the scientists who support and work in nuclear energy are physical scientists, they prefer physical measures. Physical dosimetry using a dosimeter. There's also biological dosimetry, because we are biological creatures. medical outcomes derive not from physical dissymmetry, but from the biological impact, from biological dissymmetry. In my view, the issue is that the scientific understanding linking physical dissymmetry to biological dissymmetry is incorrect. We actually don't understand very much about low dose exposures because we don't inherently incorporate the temporal aspect of the exposure in our mathematical expressions for what happens. Microdissymmetry on that scale of protracted low dose exposures, it doesn't work. That's my view. Okay, and I think the very last slide is, okay. I will leave you with these 2 points. You've been an excellent audience. I appreciate the questions. And this is a difficult topic because what I'm saying is extraordinarily radical. And if you take it to the authorities and say, oh, well, this guy says this thing, they're going to look at you like a crazy person. Because the consequences of what I have told you are really profound. But these statements are true in my belief, and try to understand what they mean and why they come about. That's a favor I'm asking of the audience. There is no such thing as a low-level exposure to ionizing radiation. Any low-dose exposure is comprised of a small number of discrete high-dose rate events that last for a very short time. And the words are a little complicated. I think the picture, take the slides and look at the picture. The picture actually, I think, is a very clear explanation of this. All right. And the scenarios of a low dose exposure, a low level exposure, and a small number of discrete high dose rate events are not the same, because a medical outcome is anchored to, in many cases, to a single event that happens in a single pulse at a high dose rate. Okay. As a result, low dose exposures are far more injurious. And I don't mean like a factor of 2, I mean a factor of thousands or tens of thousands than the authorities assert. Now that's a factor of thousands or tens of thousands times a very small number, but 10,000 times a very small number gets to be a number that might be appreciable. And I think that's the lesson of the TMI epidemiology, for instance. Okay, thank you for listening. I only went over by 32 minutes. If there are any further questions, I'm happy to answer.
Okay, we're going to start a stack now, and there's rules. So I'm going to read the rules because I never can get them. Okay, so each person gets one follow-up question after their question is answered. So if you, it's very tempting to get into a conversation with Aaron, but there's other people, and we want you to limit your questions to 2. And if you're making a comment or a long question or don't need feedback from the speaker, your comment may not be more than 3 minutes. And please do not ask a series of questions, one question at a time with one follow-up. And if there are no questions at the end, then we'll come back to you. And here's how you get into the stack. There's an icon at the bottom of your screen that says react. And if you click on that, there's a thing that says raise hand. That is the best way for me to be able to call on you. But if that doesn't work for you and you wave your hand, I'll try to find it. I'll try to do it. And there's another way, and that is you can go to the chat and put in the word stack, or I want to ask a question, or put something in the chat, because I won't be the only one watching the chat. There will be other people that are probably helping. And you will get a second chance to speak if it is not before 1/2 and no one else has their hand raised. And we want Aaron to stay for 1.5 hours, but it looks to me like that's not going to work exactly well. And it would be up to Aaron when he's had enough and really needs to, assuage his throat, because he is a little hoarse. So let's go to the stack, and it starts out with Ashley Bernot, then Roger Johnson, then Theodora Tsongas, and then Tammy. So I know some of you and call you by your first name. So we're going to start out with Ashley. Can you unmute yourself, Ashley, and ask your question?
Yes, hi. Thank you so much for doing this informational session. My name's Ashley, and I was a PTA president at Jana Elementary. Our school was closed in 2022 because of radioactive waste that was found there. And part of my FOIA request were utilized in making some of that decision. Can you give us some advice for how we should be thinking about exposures to thorium-230 and radium from the Manhattan Project, and how we should be monitoring the health of our kids who would have had exposure starting at age 3 all the way up through 5th grade? Thank you.
Wow. Okay. Ashley, this is in St. Louis, the Westlake landfill, or something?
Similar site, but different. So this is along Coldwater Creek, and similar waste as to the Westlake landfill. But this particular water source was right by our airport, and that was a outdoor holding cell for radioactive waste. And then it washed down and accumulated at the school eventually.
Got it. Okay.
I'm sorry, Erin. I need Ashley to put her email in the chat because I've been looking for St. Louis for a long time. So please.
Oh, yes, ma'am.
I want to talk to you. Okay, go ahead, Erin. Sorry.
Yeah. Boy, Ashley, I have two kids in elementary school, and my heart really bleeds for you because this is a terrible problem. But I don't have those materials are not beta emitting radionuclides, and they're not noble gases. So the work that I've done doesn't have clear applicability to your case, and I feel as a scientist, really I don't know is very often the best answer. I try to restrict myself to things I actually know about. So I'm sorry, but thanks for the question, and good luck.
Thank you for your time. Appreciate it.
Okay, Roger, go ahead.
Thank you for your presentation. I wonder if I could persuade you to move from the theoretical to the practical a little bit. You mentioned the Beer 7 report and the LNT, linear no threshold hypothesis, and so on. Another effort of the Academy was where they published 2 volumes on the analysis of cancer risks in populations near nuclear facilities. And that's been a political issue. It's been blocked by the NRC, blocked by the HHS. One of the sites to be, the 7 sites to be studied is right here in San Onofre. And they've been releasing things for over a half a century. And it's been closed for 12 years. They've done 13 releases this year into the atmosphere, into the ocean. And is this study worth doing? And why is it being blocked? And I just wonder if you would comment about this thing. People who live near a nuclear power plant, they estimate 100 million Americans live within 50 miles of a nuclear power plant, and they have all these emissions all the time.
Yeah. Well, okay, Roger, you have activated the math teacher. Is that okay? Can we do a little math? You want a practical explanation?
We could take a vote. There's more than 50 of us here, but I think it's okay.
All right. Well,
my vote is yes.
I mean, I made a slide for this, so let's talk about it. You're gonna regret what you asked for. No, I mean, maybe you will. Okay. So I do have an opinion about something called batch releases. Let's see here. All right. Okay.
Right.
So I made does everybody see this chart? There's 5 rows. It says source, milligray.
Yep.
Everybody's got, okay. All right. So the hypothesis of shot noise in radiobiological systems has to do with low-level exposures and protracted exposures, meaning exposures of long duration. All right. And here, I talk about this in the book. I think this audience is well informed. They probably know that the gold standard for radiation exposure is what's called the lifespan study from the atomic bombings. Now that organization is called RERF, the Radiation Effects Research Foundation. But let me just give as an example, the principal component of the exposure from the atom bombs had a dose of 39 milligray. I'm now looking at this row here, 40 milligray, And this was the secondary gamma exposure, so it actually had a duration of 10 seconds. I work out here that the dose rate, and this is trivial, is 14 gray per hour, okay, which is a moderately high dose rate, but it is in the shot noise limit, for which the shot noise is a important component. I calculate what I call the number of double strand breaks that are produced by this radiation in a cell, and I got 1 double strand break out of 1,000,000 cells. This is in units of K squared, and it's a peculiarity here. I don't yet know what K is, but I want to compare that to a chest X-ray. All right, so the atomic bombings made one double strand break out of 1,000,000 cells in this weird unit. A chest X-ray that has a dose of 0.15 milligray, a fraction of a milligray, and lasts for 1/10 of a second, which is the typical duration. The dose rate is 5 gray per hour, which is about the same as the atomic bombing. And the double strand breaks that are produced, because the duration is far shorter, is of the order of 10 to the minus 11th. So that's 10,000 times fewer than the atomic bombings. That's good. A chest X-ray is not causing harm to my cells like the atomic bombings were. But now I wish to refer to a difference, the third row here. Suppose there's a batch release, and I went into the Federal Register. It's called 10 CFR 20, and I looked up what sort of batch release is allowed. And it turns out you can release from an operating nuclear reactor krypton 85 if you happen to have that, in the reserve tank of the reactor you need to purge. And as long as that krypton 85 doesn't cause more than 0.02 milligrays of exposure of dose to any individual within 1 hour, it's permitted. So that's the law, it's legal. I calculated the dose rate, and I calculated how many double strand breaks would be caused in that individual enveloped in that cloud. And the answer is 2 times 10 to the minus 7th. Okay? Do you follow, Roger? Is this making sense?
Yes, but this is, I would be interested when you get done with this to move from the theoretical to practical. Should we be doing this NAS study, epidemiological study?
I'm almost done with your question, okay? But thank you. I was just trying to make sure I'm making some sense. Compare the effect of the batch release to the atomic bombings, and you see a batch release is only 5 times less dangerous than the atomic bombings. Okay, so Roger, I think the answer to your question is, if you thought a permitted batch release was only 5 times less harmful than an atom bomb, would you conclude that the study should be conducted?
Well, first of all, don't have a lot of respect for that atomic bomb study that was done after the war. There's all kinds of politics involved, and but that's beside the point. I would like to see an epidemiological study done. Yes.
Yeah, I agree with you, and I think it should have been done, and I was angry when they decided not to do it.
But it's still up for grabs. Congressman Levin is still trying to get it done, but all the government agencies are blocking it because of pressure from the nuclear industry.
Yeah, I hear you. But anyway, I have told you what I can tell you about that question based on the hypothesis that I'm discussing.
Okay, our next questioner is Tammy, and Tammy has a blog. She lives near the Idaho National Lab, and she's been our expert in the past. So Tammy, ask your question.
Thank you. Can you hear me?
Oh, yeah.
Okay. I looked at 3 Mile Island issues, the accident and a lot of the epidemiology, and I wrote newsletters, a series of newsletter articles in the last 2 years that are on the Environmental Defense Institute website. the cause of the accident was so egregious, there was a lot of reason to cover up. And the insurance companies were contacting the control room, that morning. They were keenly aware of not wanting to pay out claims. I looked at the dose estimates, and Jan Bayou, who is listed as an author on some of the epidemiology studies, did excellent work to use mapping of the dispersion of radionuclides. So that picture of the relative density of the deposition over time because of wind mapping that they had, he did that mapping, but he had also a lot of commentary that the estimates of the total amounts of radionuclides released and the estimates of the doses were highly flawed. And I think that they've been put forward as factual, but I think there was a lot of fudging on the total amount that was released, and there was fudging on the monitoring that was conducted. It was spotty. There were different releases through time. They were not keen on, they weren't even monitoring in any comprehensive sense in those first 24 hours, first 48 hours. It's spotty. It's all over the place. So the wind dispersion was precise, but the total releases and what was released when and what hours, I think that I think the doses are higher than what the authorities have said. And, when Stephen Wing did his epidemiology, and he was allowed to utilize that wind dispersion, which you put up the map of the relative doses, he was told, but you don't know what the absolute dose is. So you can't scale it to that. You just have to stick to what the relative is, but we don't know what the doses people were getting were. And he could show in those higher concentration areas, because of the hills around, the dispersion, wasn't even because of wind direction and the hills. Anyway, I do not believe that the doses are as low as what the authorities say. And the leukemia cases, as they do, I forget the name, when you look at several epidemiology studies combined, there's a set of studies that looked at leukemia, and TMI is included in this study of a group of studies. And the leukemia rates for 3 Mile Island, for the doses stated for 3 Mile Island, mean that the 3 Mile Island doses were whoppingly effective at creating leukemia like nothing else ever has been. And I believe the reason is that the doses were simply far higher, depending on where you were in the plume and how many hours you were present at your home and everything. But it's been pointed out that by Helen Caldicott that Hershey's chocolate had hired Penn State to do testing, and they found hot milk, iodine 131, that was way hotter than anything the authorities were mentioning. So the last thing I'll say, is that Chris Busby of the UK pointed out that the Navy's study of naval personnel, which was conducted to poo-poo that there was any harm to naval personnel from Fukushima and ships stationed near Fukushima, they did a study just to poo-poo that. Chris Busby looked at their matched control of 65,000 naval personnel with their doses monitored through the years. And this, was looking at the people who were alive in 2011, a matched control, but an age distribution that would match a population on a ship. And he compared the rate of cancers, not cancer death, but cancer incidence, to the US SEER database, the epidemiology database for the US. And the naval personnel with their average doses of less than 2 rem per year, less than 2 rem total, had 9 times the cancers expected for us general population from the SEER epidemiology database. And that cries out for investigation, serious, independent, scientific investigation, because yeah, the Navy's fudging and lowballing the doses, but I think it's more than that. So I'm done now.
Okay, thank you.
Was there a
Yeah,
question
that's
from you?
the naval. I don't think there was a question. It was a comment, right?
Well, it is, I mean, it is a comment. I totally agree that the harm being done per dose is higher than the models from what I will call BEIR 7, BEIR 7, that the actual harm is a lot higher. I think the Navy study points to that. I think the harm at TMI would be underestimated if we looked at the official models, but I believe it's underestimated in large part because the doses were far higher than what officialdom ever wanted to admit.
Okay, Tammy, I think we should go on, and your comment is really very interesting. But let's go on and ask Carolyn what her question is.
My husband lived 30 miles away from 3 Mile Island during the accident in Carlisle, and worked 15 miles away in Mechanicsburg, and so this was mostly west. And I personally would like to find out good source or good sources of information about radiation exposure in the area. And I've seen, I saw your slide. I've seen a few things from previous talk or two, and I was just wondering how. I mean, what can I read? What is public information that would be good information about um, the the releases, the exposure to the people in the area?
That's a good question. Okay, would you like a somewhat complicated answer?
Sure thing, whatever. Everything's complicated.
When the accident is discussed, we're almost always talking about emissions from the vent stack of the auxiliary building and not from the reactor itself. So there were 22 million, and as Tammy's comment was made, I've read all of Jan Bea's papers. I read the 700-page dosimetry workshop. I read the 100-page assessment where he did the modeling again. That's all about the auxiliary building. Now, in the dosimetry workshop, someone points out, and this is correct, that if the core melted, and the dosimetry workshop occurred in 1984 before the authorities were willing to believe that the core had melted, that they had no idea what got out because actually the steam vent valve was open for the first 7 hours of the accident. Later on, it came out that actually the thing probably melted really quickly, partially melted. And it's true that the steam vent was open when that happened. Whatever escaped in steam went up high and landed outside the 10-mile area and has never been counted, and nobody knows what it is. When I travel into this community to talk to people and take blood samples, the stuff that happened inside the 10-mile area kind of makes sense with the xenon exposures. I sort of understand that. There's a lot of illness, a lot of strange illness in other areas, Mechanicsburg, York, and Lancaster counties. And my suspicion is that the stuff that went up in steam came down in those counties, and those people were exposed at a very low level that was unmeasurable, but it was there. And now, when the accident happened, the authorities said, well, cancer doesn't happen for 20, 30, 40 years. Nothing's going to happen. We don't need to measure it. And then the investigations they funded out of Pitt ended in 98, only 19 years after the accident. And now people have all kinds of problems. 40 years later, people have all kinds of problems and nobody's looking. Unfortunately, the authorities finally conceded that the reactor melted in like 1988. Nobody has ever gone back and done an assessment of what came out of that reactor in steam in the first hours of the accident. Because when attention was on and they were working on the problem, they were focused on the auxiliary building vent stack and they didn't think the inside of the thing had melted, so they thought that nothing went up in steam. And I think that assumption is wrong. But unfortunately, Carolyn, I don't think anyone has the answer to your question. I think that's an open research area. Is that an adequate answer to your question? Once again, I find myself saying I don't really know.
Yes, that's perfectly fine, and we'll never know. My husband has had 3 separate discrete cancers, and I just can't help but think that 1 or 2 of them are probably 3 Mile Island, or a combination of living in Pittsburgh for 6 years plus 3 Mile Island or something like that.
Hey, I have heard more of these stories, and they break my heart every time, and I'm really sorry. But
he's fine. Just wanted to, it's more speculation, and hope he doesn't get a 4th one. Anyway, I didn't mean to go on. Thank you very much.
Thank you for the question.
I'd like to, before I go to Ace, to look at the chat for just a minute. And there were a couple of questions in the chat. One was a comment by Mark Lundholm. And I'm just going to read your comment, Mark, because time's going by pretty fast. It's especially disconcerting that the DOE and so on contemplate reopening several shuttered nuclear plants, supposedly to power AI energy demands. This is off topic, and it's something we discuss a lot in our meetings. And then Jill Long, who's here, she's asking the question, can we test the soil for cesium-137 and strontium-90 like they did at Chernobyl?
You can always test. The answer is, they did some of this at the time, and they didn't find any. As I said, if it melted early and it went up in steam, nobody really knows where it went. And by the time it came down, it was probably too dilute to really find against the background of, there's a background of cesium everywhere due to atomic bomb testing. So how would you really tell it was from 3 Mile Island if you managed to find it? I will say, pursuant to the steam, someone said they thought that was interesting, and I will say 2 more things about it. One is, one is, if you go back to the EPA RadNet, which is online and you can look it up, there were elevated levels of iodine measured in Pittsburgh and Philadelphia in the months after the accident. And that's there, they found it in the labs. And then it decayed away with the iodine-131 has it's an 8-week half-life, if I remember. It's 8 either weeks or months, but it went away. So that went somewhere. Where did it come from? I think it came from the steam vent. They didn't find much iodine. I will say, Tammy, I heard your mention of Helen Caldicott and hot chocolate, radioactively hot. And I read that book, and actually there's a mathematical error in her expression of curies per liter of iodine-131 in that book. So it wasn't as hot as the book says, although it was hot. That's a problem. The other thing is, if you map out the counties in the U.S. where thyroid cancer is highest, they are all counties that were downwind of 3 Mile Island at the end of on March 28th and 29th, 1979. and there were all counties where it was raining that evening. There was intermittent rain in those locations. So I'm from Quakertown, Pennsylvania, in Upper Bucks, Southern Lehigh County. Lehigh County, where I grew up, it has the highest rate of thyroid cancer in the country. It's a place downwind of 3 Mile Island. It was 80 miles away from 3 Mile Island, and it was raining on the evening of March 28th, 1979. Well, why should that be? I think the answer is, well, there was iodine in the steam, and it rained out over my home. And in Westchester County and in Lancaster County and other locations with high rates of thyroid cancer today. Okay. I actually forget how I got on that topic, but that's all I have to say about it.
Okay, now it is 20 after 8. And so I'm going to call on Ace and Jake and Linda, and then it will be up to Aaron if he wants to continue, because our meeting is really an hour and a half. So wait, oh, Ace, what happened to your hand? Okay,
I took it
Ace,
down.
yeah,
Can
you're
you hear
going to
me?
be the next.
My wife and I read your book, and we thought it was wonderful. And I've been studying this for like 50 years. And one of my friends back in the day was John W. Goffman, of course, the Manhattan Project scientist. When I knew him, he said, yeah, that guy. When I knew him, he said to me one time that he did not understand how Ernest Sternglass could be right about LNT. About it being supralinear. He then eventually changed his mind. So in 1990, to give you a quote from John Goffman, I just want to read this very quickly. The new A-bomb that would be new in 1990, the new A-bomb evidence shows when all ages are considered together, that the cancer hazard per dose unit is more severe at low doses than at intermediate and high doses. The dose response curve is supralinear. So it seems that there's an awful lot of agreement with what you've written, and my wife and I couldn't find anything to disagree with. We were very impressed. But I will say to everyone who wants to read the book that what we heard tonight, I think, was the best explanation of any of this that I've heard from anyone. And I've talked to Ernest Sternglass and Helen Caldecott and John Goffman and Richard Webb and many, many other people. And you've really topped all of them. I'm very impressed. Thank you so much.
Oh, well, that makes, actually, I thought chapter 7 was a hot mess, but thank you.
Compared to your speech tonight, it was, but
that's very kind, Ace. Thank you.
Jake, what's your question? You have to unmute, Jake. Okay, Jake, we're going to come back to you because we can't hear you yet. You need to figure out how to unmute. I think it's
can you hear me?
Oh, yeah.
Can you hear me now?
Now we can hear you. Yeah.
My question is, you said the statistics from Russia are unreliable. Why?
I didn't say that.
I misinterpreted it. What did you say about Russia?
Let me backtrack and give a little background, and then I will. Okay, so there was cytogenetic testing in 1994-95. I talk about it.
Could you get closer to your mic, Aaron?
I'm sorry, sure. My voice is letting out. I'm sorry.
Yeah.
There was cytogenetic testing in 94-95. The scientist who coordinated it was named Vladimir Shevchenko. He's no longer alive. His colleague who performed the analysis in Russia, her name is Galina Snigureva. She's still alive and working in Moscow. I've communicated with her once or twice. The testing was done in a great hurry because the lawyers were overmatched in the lawsuit. It was part of a legal proceeding. And they were never published in the peer-reviewed literature. Nevertheless, there were a couple of conference articles about it. Now, the article that I published in Scientific Reports, which is not a highly respected journal, but it's open access, and that's why I chose it. I tried to publish that article. I think it's a good article. It's good work. In a peer review, in a prestige journal called Radiation and Environmental Biophysics. And they sat on that article for a year and a half. They sent it out to 6 different reviewers who had mixed opinions. And in the end, they rejected it. They wouldn't publish it. And I hassled the editor about it because I thought, one of the reviewers said it was fascinating and should be published as is. And I thought that was really good. And the editor basically told me that he had to reject the article because he didn't find the cytogenetic results credible. No one believed them. They are, literally incredible in his view. And when I shop around, talking to other scientists, the conference proceedings from the Russian scientists, they look at this and say that, we don't respect this. I think there's some element of chauvinism there, but I took the approach that I thought was scientifically best, which is to try to replicate the results with better technology in the present day. And so that is what we've done. Does that answer your question, Jake?
Sort of. I think part of it they after the Chernobyl accident, they were trying to cover up the accident. So part of what they did, I know about Dr. Charnyshenko, right? He called the International Atomic Energy Agency the nuclear mafia. He essentially charged them.
I think there was a Chernosenko who was an author. I have a couple of his books.
Charnyshenko, okay, right.
Shevchenko, who was an ecologist and a radiation specialist, and those are separate.
Oh, you're talking about 2 different people then.
Yeah, I think so. We're talking about 2 different people.
Oh, okay. I'm sorry, I confused them, but okay. No, I think the Soviet government was desperately trying to cover up the accident, and part of what they did was skew the numbers. That's my understanding.
Chernobyl is related to this story, but after the fall of the Soviet Union, there was some more openness, and that openness was actually how Russian scientists came to investigate in central Pennsylvania.
Yeah.
Thanks for your question, Jake. And we're now going to go on to Linda Brosh.
Hiya, Linda. How you doing?
Hello, Aaron.
I miss you. It's nice to see you.
It's good to see you too. I want to thank you so much and all these scientists and everything, because I'm a mother and I don't understand everything. I am grateful that you work on this to find out solutions, and that's what we really had worked on as mothers, to try and find answers for the health and safety of our children and the common good of humanity. Now, I did want to ask you, Aaron, if you've ever had the opportunity to go to the Smithsonian Institute, where one of our, she's passed now, but
Mary Olson's leaf collection.
Yes, as she had a lot of flowers and different things that different items and animals and whatnot that were large, and leaves and different things like that she was able to have put in the Smithsonian Institute. I guess Scott Porchline helped her with that.
Yeah, I gotta, I live right there. I gotta get down there and do that. I wanted to take pictures and put them in the book, but I didn't get it done.
Well, that's very good, but I didn't know if you were aware of it. That's all. I'm sure you probably are.
Can I make one point about that, Linda? Do you mind? The rose is from Joyce's backyard.
Joyce's backyard. I had one in mind, but I killed it. I had some forsythia that had things on them that we were trying to figure out what they were, and they got discarded. So, but she had, I know that Mary had a lot of things, a lot of items. So
are you talking about a rose?
Yeah, there was a rose that had a rose growing out of the middle.
Oh, yes.
One rose.
You see those.
Just different abnormalities that you really never see. I think is
one little told story about TMI is that tree cores and abnormal growth patterns in the trees were a big part of what Shevchenko did for the lawsuit. They took cores of more than 80 trees and they sent them back to Russia for examination.
Mhm.
And
That was also, some of that was also from Joyce's backyard.
well,
Joyce had an interesting backyard. I can remember when we helped with the health study and I walked around and I did interviews that and asking the same exact questions to different households, that where we were, there was a lot of farming and the people had never seen or had so many horse miscarriages.
Oh, yeah.
There was a lot of that happened. And we knew friends who had moms who had lost their babies. And so, the questions just kept coming as we started learning about different things. And so we persevered. But I did want to stop and get on here and say thank you. Thank you. Let us keep going on and find out what's right, because I'm not sure that this nuclear stuff is something we're supposed to be messing around with. In a way that it is being, because it does not have truth to it. There's no truth to it that I can see yet. And the work that you're doing, I thank God for. So, and thank you, everybody. It's much appreciated.
Well, our time is up, everyone. And I never did properly introduce Aaron, but I don't think we need to anymore. And I am going to turn the time back over to David Kraft, who is the Director of Nuclear Energy Information Service, with a huge thank you for Aaron. This has been a lovely, lovely meeting. Thank you so much. David?
Okay, thank you. Yes, I also thank you. Before I move on to some of the housekeeping, I want to point out that one of the beauties of Night with the Experts, which evolved since the COVID epidemic, is that we have been able to reach people from not just within the United States, but around the world. And tonight we've had several guests who are from Japan who have been listening to the presentation, one of whom put a question in the chat. And I just wanted to give an opportunity to our guests from Japan if they wanted to ask specific questions, or, Aaron, if you want to take a look at Yoshiyuki's question in the chat and answer it, we could reply to that.
I will look, just a moment.
You can put yours back on. I can't figure out how to save it.
Hit the chat at the top and the three little dots.
We will save the chat automatically and send it around later, folks, so you don't have to worry about that.
The question is, how and what do you request to ICRP?
Let's say what ICRP is.
Okay, the ICRP is the International Commission on Radiological Protection. That is an authority in the same sense that the National Academy of Sciences is an authority. That is a really interesting question. How and what? All right. That's a great question. I'm gonna say give the following answer. I've presented a hypothesis. It's a mathematical hypothesis based on detector science, in which I have academic expertise. Jan asked the question early on, what does it mean to be falsifiable? And the answer is that if I took a tube of blood from an unirradiated person, and I took that tube of blood and I dissolved in the tube of blood a very minute amount of a radioactive contaminant, a radionuclide, and I let the blood sit there, the blood would be irradiated and chromosome aberrations would form. Now, I could put only a very small amount of this radionuclide in the blood, such that the blood would receive a very low dose that is protracted for hours. And then I could take the blood, just as we took the blood from the people at 3 Mile Island, and I could look for chromosome aberrations. I have developed a mathematical model that allows me to predict how many chromosome aberrations I should find. it's a low dose exposure, the prediction of ICRP or beer, BEIR, should be that I would find no or very low level of chromosome aberrations because the dose is very low. If my mathematical hypothesis is correct, I might find a high level, in which case my hypothesis would be confirmed. So if I had the possibility to request something of ICRP, I think a scientist with an equipped laboratory should be engaged and given funding to do that experiment I just described, to either confirm or refute the hypothesis. I'm satisfied with that answer, I think. Thank you for the question from the person from Japan.
Yes.
Okay.
And I'd also like to thank those of you from Japan who joined us tonight. All right, Aaron, it's been a terrific evening. You really struck a lot of chords, both in the chat. I've seen there's a lot of discussion. People are very enthused about what you did. I would invite you, if you want to put another plug in for the book or how people can reach it. And with your permission, I would also like to extend a couple of an opportunity for Heidi Huttner to put something in chat to promote the movie. We will leave the chat open for a little while, and it will be sent to everyone, and that'll give everyone an opportunity to see the movie. So with that, I want to thank you. I would ask if you just stay on a few minutes after we shut down the meeting, Aaron. I have a little business to transact with you. And for the rest of you, you will be receiving the chat tonight. Zoom has been very good about giving us excuse me a minute, giving us the link to the presentation pretty promptly. So it should be available in the next day or so if people want it. And we would be happy to share that with people. I also want to mention that this is our last presentation for this year. We're not going to be doing one in December because the last Thursday of the month collides with the holiday season. So we'll be starting fresh again in January. The last Thursday in January is January 30th. And we are inviting you to let us know what topics or what presenters you might want to see in 2025. I'll give you a little teaser right now that I've had a little preliminary conversation with someone many of you know, Mary Olson. And it turns out that she and Cindy Folkers, who was on this session tonight, are collaborating on a project. And I'm hoping that we'll be able to have them on as guests sometime in the middle of next year. But that's the caliber of guests we would really like to have on these and to give you a chance to have dialogue with them. So if you have suggestions of presenters, topics, please send them on by email, neis@neis.org. All right, well, we thank you all for joining us and wish you all a happy Thanksgiving, and stay well.
I did post the information about the film, by the way, and where it can be seen, which is Amazon Prime and Apple TV. And also we welcome invitations for screenings.
Excellent.
Thank you.
Excellent. Thanks.
Thank you.
Thanks, Heidi, very much. All right, everyone. Thank you and good night.
Thank you so much, everybody.
Thank you. This is really good.